Let's see how this goes. What's the plan for today? Well, we did. Give me a second. After these tests run, what I'll do is I'll recap for people what we have done lately and then just describe what we're going to do. Uh, 1 second. Okay. I did a stream a couple days ago where I started talking about copy elision, and you can see that's going to be still in the VODs for now if you want to go back and watch that. But the upshot was, we had code generation that I didn't love. So this was an example that just calls a few functions, right? That return structs or integers. And this is the bytecode that's generated by the compiler. And there's instructions in here that we didn't love. Like we generate this into V7 and then we mem copy, and like, why didn't we just put it in the right place and all that, right? So we actually fixed that at the cost of some code complexity, which I don't love, but wait, I made it. I put it here. Did I mispaste? Did I double paste? Yeah, I double pasted the program. All right. Anyway, here's the output that we see now, and um, you will note that it's much cleaner. There's just the calls. There's one mem copy at the end for reasons of we don't have alias analysis that tells us that it's okay to modify this thing. But the rest of them, so this is 11 instructions, whereas the one up here is 18. So that's a substantially smaller function, which is good for everybody. Okay, so we also ran this on the Sokoban game, of course, because it's the compiler that we use every day. So Sokoban started at 775,000 instructions, and it went down to 750,000 instructions. So that's a good 25,000 instruction reduction. Which is that's pretty okay. Yeah, the Weissman score has improved. Um, so the thing is, so sometimes in the process of doing these things, I have to make a little bit of a mess, or they get complicated and I'm not satisfied with how complicated they are, and I try to simplify. Okay. Let me see. Let me try to describe to you how we're doing this, right? Because naively, as you would see from Sam's talk at Better Software Conference, or just if you ever write a bytecode generator, when you naively output bytecode, you get a bunch of extra instructions. Like this is actually kind of mellow for what you might get if you're super naive about it. Um, I thought I had a papers here somewhere. Um, no. Where's the papers? Maybe it's not in doc. Dude, we have all these docs that nobody ever looks at. That's just how things go. Wait, supplemental? Dude, I just have notes somewhere on. Let me just try to see if we can find it. Closures, no. Like, you used to. Maybe it's. Maybe this will link back. Like, just everything sucks now. Okay, this is going to be. I don't remember if this is the paper. So far, it's a bunch of irrelevant crap. Why am I looking at fucking denotational semantics? This has nothing to do with anything. Okay. I don't know. This doesn't look like the paper, but it might be. I don't know. But the point is that what is the point? Okay, so this is the way that we achieve this slimmer code generation here is when we call around to things to generate code, we just pass in a little data structure that says where we would like the result. That's all. The thing is, it sounds simple. And it is simple conceptually, but what always happens is it turns into a bunch of ugly code that you would prefer not to be so big and ugly. And we're looking at that now. Okay, so we ran that test. And we're running this test. Okay. So I think this is fine. I don't remember if we made any modifications after we ran the test. So I have this thing called make procedure call info. It makes a data structure that the bytecode uses to know where the registers are, where this thing should go, and all that, right? Among other information. And it blew out massively when I added all this fucking code for return values. And this doesn't even count all the places that try to send the placements in, but it's fine. Does the bytecode have complete feature parity with the compiled form? I'm not sure what you mean by that question. The bytecode is an intermediate representation from which the compiled binary is created. And so, yeah, it sure better have all the functionality we need. Otherwise, we won't be able to do anything. Okay, so I'm just trying to put these loops together. So what happened was this loop here was in one place in the code, and it handled like small return values for reasons, right? Wait, which loop? This thing that I just pasted up here to the not handled. That was in one place. And this for big return values was in a totally different place in the code. And it was very confusing and made me sad. So I'm putting them together now. And the way this ran, if we didn't handle things here, we would create a value number. And then down here, we would overwrite the value number later in the code. That's messy. It creates holes in the value number space, and it's just inefficient, right? So what I want to try to do now this is a little bit tricky. Do we use this return index variable? No. Let's get rid of that. So this if statement about value placements, I believe we could move that out. See, this was duplicated because the code was in both places. That's not great. So I think we can just do this. And I'm just going to be... This is a very cucked millennial way of doing code. I'm just going to keep running the tests. And the reason why is because this is an area where you could mess something up that's subtle and it would only... We had that last night. I broke something and it only broke like 2 tests out of the 1,000 tests, right? And it was things that you could normally run lots of code and not worry about. Any useful insights from Sam's talk? I talked about it already on stream. Maybe somebody has excerpted the blurb. Yeah, the bytecode is both used to do compile time execution and it's used to generate the final machine code functions. That's just how we do it. I'm sure glad I bought this AMD Threadripper 5 years ago. This has been the best computer I've ever owned, except for the fucking operating system. All right. Okay. So we have factored that. That's good. We reduced some lines of code. We moved this out. We've got our placement. And I believe we could now... I believe we could move this up, but it's going to require... Okay, hold on. Let's do some more. So there's this result def in here is the same as return type. So let's delete that. We're just going to make sure that compiles. And you know, we should actually take a W soon and check things into source control. Okay, if the tests failed, the first thing we did after they succeeded was return type. Okay. So basically, so now this looks kind of small and reasonable. Like here's what we do for small values. And we could put the big values here. And the big values are here. Okay, but first, see, we've got this return info. Instead of reading this and then writing it back, let's do a step there. So does anyone else use result register? No, that's a different function. All right, so we're going to say return info RI way up here. Job is to fill this out. And instead of saying result register is this and local register is that, we're just going to set it up here. Okay. Otherwise, now the whole reason we're doing this is because we want to get rid of this array, by the way. This array is redundant with this value, and so we want to get rid of it. So let's see. How did that go? And if it passes tests, we can take the W and check into source control, and then we'll keep going. The next step is going to be to combine this with this, and that moves this whole block across this not handled. This not handled thing is the one that creates all the gaps in the value number space, right? So we'll get rid of our gaps in the value number space. And we'll get rid of the overwriting of things, right? How we doing? Wow, that's so fast, dude. Those of you know who have been watching the stream that before I moved back to this apartment, I was using a computer full of European cores. And I switched to that just because it was newer than this computer. This computer is from 2020. This computer is from January 2020. All right. However, let's try something with graphics. However, this computer is just better. Like my 5-year-old, 5.5-year-old computer is better than this 1-year-old computer. So we got rid of the European cores, and the tests, as you can see, run way faster. We were looking this up, by the way, last night. Wait. Did I close my tabs inadvertently? Hello, chat. I guess I closed the tabs, but this is the chip that I have. Oh no, here's our compare. Okay. This is the chip that I'm running right now that I bought in 2020. It's still, if you are going to buy this CPU today that's 5.5 years old, it still costs $1,700. Okay? That's how good this computer is that I'm running on. What are European cores? They're cores that don't use very much energy. And are very slow and don't let you open the window or take the cap off your beverage. Anyway, yeah, so this is what we're running again. I'm so happy to be back on this computer. I wish I had never switched to the other computer. Yeah, I saw the thing about the European TVs as well. Dude, why anyone would live in Europe right now, I have no idea. I mean, there's a few nice things about Europe, but they're rapidly like they've given up on the idea across all of Europe, including the Brexit. They've given up the idea that they should be a first world civilization. Or their idea of a first world civilization is that somebody badgers you with stupid rules all day and you have to do those things. And then there's no energy left, like no personal energy left. There's also no actual energy, but there's no personal energy left at the end of the day to like be creative or joyful or live life. So so I'm happy to not be there right now. You live in Europe but not EU. Yeah, that's probably good. Like who's in the is Poland in the EU? It is. That's sad. Cuz I was thinking Poland could be good. Like I feel like somewhere in Eastern Europe that is not in the EU is the right place to be. Okay. Our test passed. We're going to take the W on that because we're in scary territory. Okay. So, by the way, Raphael, what I'm working on right now is the value placement system, which I'm sure you've seen. It's the thing that the bytecode generator uses to get relatively terse bytecode, right? And I added some handling for a couple of cases, so our bytecode output is better. However, yeah, I don't love how complicated it is. So at some point, there can be some assessment of like, how much code is it to do these value placements and what's the bug risk due to how complicated it is? And like maybe, this idea of like optimizing bytecodes as soon as you output them. Um, maybe if that's fast enough and it can replace all this freaking code, maybe it's better. I don't know. Um, yeah, what like I think I mentioned this the other stream, but I was also thinking about, lifting values out of loops, which sounds hard, but it actually seems trivially easy unless I'm missing something. So, you know, some of these optimizations we could add in a pass or something. I don't know. Anyway, I'm trying to clean up the value placement code and remove some redundancies in both in what was there before and then what I added the past few days. Because we don't want it to become a bigger mess than it is. All right. So here we've got if it's not treat as big argument. Um, and now we can go else. Okay, we'll keep this size greater than 0 here. Okay, and now instead of overwriting this value, because this is in the else, and well, specifically because we're crossing this now, that value doesn't exist now. So we're going to go dot add instead. And we're going to go handled equals true here. Now this is a little bit I think this was messy and wrong. Like before, we would have done a register assignment from this loop, but then I think we put storage for big return value, and then people have to ignore the register if this is set. But the thing is, the register is still misleading trash information. But maybe some code was like incorrectly using that and we'll freak out now, right? Okay, so now this is brought together and makes more sense. All right. Um, oh God. Yep, we broke something. What did we break? A lot of things, probably. Instruction call procedure, vreg XSR, I greater than equal to z. Oh, yeah. So this is probably what I was literally just talking about. Like, so, I mean, maybe I'm wrong about what I'm saying right now, but I believe when we say storage for big return value, we should not do this. Um, but let's try not doing this for a second. And that way we'll fall through and do the register assignment. Yeah, and now it works. Okay. So here's the thing. We don't know who's right. Maybe I'm wrong in what I just said, and that register assignment is actually used. Or maybe there's a bug in the code. The code is confused and it's doing something wrong, in which case we can root that out. Now, that's an interesting thing about code, guys. It's underrated, right? What happens a lot as programs age, they get bigger. And so some parts of the code, rightfully so, just sort of freeze and they're not really edited anymore. And sometimes that's because that code is stable and dependable and you understand it well and you don't, it's done, right? You don't need to mess with that. And that's great. And the more that we can do that, that's good. Sometimes it's because people are afraid of that code and don't want to touch it, right? And that is no bueno. And the benefit of actively working on code is when things have not been messed with for a long time, maybe they're still harboring bugs that you haven't seen, right? And by perturbing the code, by messing with it, you can figure that out. All right. We could check this in, but we're gonna bring this back, and will this break on a simple thing? Yeah. So we're gonna I think that's what we're running here. No, we had meow hash. Meow meow. Meow meow. All right. So what are we doing? vreg access w. Okay, this code looks wrong. We literally say maybe -1, and then this just fucking subscripts the array. Uh, got a -1 emit result, but the expression size was non-zero. That's probably wrong too. See, and the thing is, like, okay, the thing is, it looks like we caused bugs, but we didn't really cause bugs. What happened before is these other checks are a little bit overzealous and wrong, and they were only working. Um, you know, they were only working because we didn't think hard enough about it. Um, okay. So we did emit expression for the procedure call. I see. Okay, so here's the thing. If that first, let's double check where this is before I say what's happening, just so that we can show the source code and validate what I'm saying. All right. Um, so this is in um, runtime support. Okay. 232. Yeah. Okay. I'm a little bit. So what's happening? A string is a large value, right? And so we are, I guess we're generating a placement for the string that is the argument passing register or something. I would have guessed that there's no placement here, actually. Um, but I think the deal is that I'm smoking crack a little bit, and that that value number is actually being used to refer to the L value of the thing, I think. So we actually do want it there. Because, so when you call emit expression on toString, right? Like it could put the string in the memory, but it wants to return back a value number that tells an art, because we don't know where emit expression is getting called from. It gets called a lot. So we want to return back a value number that represents the L value. Now the question is that what that value number is actually used for? Right? Um, so this part just does the stack part, right? But if someone's going to refer to the value on the stack, we still need to have that. So you know what? We're going to not handle this. No, you know what? We'll handle it. Um, okay. So we're going to do this. Now, what about this? Maybe, okay. So we don't want to pasta all this. So this lowest created value number, do we actually use that? That I had an idea. That's a new thing that I added. Literally nobody ever uses it. So you know what? We're going to take that out. The idea was if you want to know if some value number was given to you as a placement from outside or whether it was generated by this call as a temporary value, then you just check the value number against that And if the value number is higher or equal to that, then you know it was created in the call, right? Okay. Dude, you guys think smoking crack is bad? Hunter Biden normalized smoking crack, and we all know that he was an unimpeachable personage. The the news media has been telling us that for years. I mean, it's okay. It's okay if you just find a bag of cocaine at the White House. Like, there's no cameras at the White House. We can't figure out who left that bag of cocaine there. Come on. There's no way to know. There's no way to know. Not sure if I saw the messages. Let me scroll back. That's related to the Dominator tree. Yeah, we have a Dominator tree, dude. Um, but it's not even related. It's not even actually related to the Dominator tree. All you need to know, at least as far as I've thought through it, all you need to know is like what value number were we on? Okay, if you're SSA, which we are not currently, then what value number are you on when you start the loop body? And then anytime you're going to output an instruction and that instruction's inputs all have value numbers less than wherever you started the loop body, then you know that that does not depend on anything inside the loop and you can move it out, right? Now you have to have a place to put it. So that's the thing that we also don't have right now is a place to put those things. And that would be a thing, you know, like generally once you start optimizing bytecode and moving things around, you need like a way to do that. So now that doesn't mean you definitely move it out because there's all these questions like, you know, maybe you're 3 if branches in and you don't want to move this out of the loop because it's rarely done or something. I don't know. I don't know. Maybe that's a hypothetical made up case. But the point being, it doesn't actually seem that hard. Um, After the bytecode, we emit a metric ton of read from the bytecode register and write back to the bytecode register instructions for every instruction. Have the feeling we could emit a lot of those writes. If we had the simple flag, this is the last time this bytecode register is read. No, I don't. Okay, so this depends, I think, also on which backend you're talking about, right? Um, on the LLVM backend, as far as I know, now you've done more LLVM than me, so you can let me know how accurate this is. But on the LLVM backend, there's no such thing as like registers yet, right? Like that's registers happen after a mem to reg pass. So like everything is stored in memory. And so the memory that we use for that is, you know, this we have an array for all the value numbers and there's a memory location tied to each of those. And yeah, every time you change a value number, you have to write it and you have to read it when people use it. Um, As far as I know, like I hate that. I think it's very inefficient for LLVM, obviously, but I think that's just the way it works. That's what I would. That's the opinion or the guess that I always had. Um, Now in x64 backend, uh, that's more just maybe the register allocator isn't doing a good job, right? Um, so we do. This is one of these things also that'll change. Um, we have a little bit of a Heisen behavior with respect to this, because if you ever print a variable, that gets casted to any, right, which takes the address of the variable. And when variables have their address taken, all of a sudden you don't know for sure that they're local. And that's one reason why you have to write back the value every time it's changed, because somebody else in the program might have a pointer to it, right? Um, I mean, we could do more sophisticated analysis than the pointer is taken. Maybe the pointer is taken and escapes somehow or something. Or maybe we just change casting to any so that it's only guaranteed to be the value at the time the variable was set. And so then if it doesn't track changes, you're kind of fine with that. I'm not sure that's a good idea, but maybe it is. Um, like I kind of would either want it to be it's guaranteed to track changes or it's guaranteed to not track changes. But you know, when you get into these compiler optimizations, it's like a middle thing always. Um, anyway, yeah, I agree that this stuff is a hassle, but it's not totally obvious to me what to do about it. Um, you meant the value number array on the stack. Um, so do you mean the x64 machine code specifically? Um, so what I will say about I have gone crazy trying to do x64 debug builds as well. Um, the stuff I did over the past couple of days actually helps that a lot because like anytime you call a function, like everything was getting copied to intermediate locations and then to the places where they were going to go. And like that was like you're looking at machine code, it's just really hard to trace that out, right? So all that's gone now. Um, but yeah, I mean, to the greatest, to whatever extent we can get rid of those things, we want to do that. Should talk about this in a call. Yeah, I agree. Twitch chat is not the best. Twitch chat is not the best. Okay, so okay. Okay, I think we're going to run the tests again. And then we're going to check this in. And then we're going to try to get rid of that extra array some more. Have I considered Patreon to fund development? Not really. Maybe a little bit. Um, yeah, the question is just who would sign up for it. I actually thought about Substack. Um, and just like posting compiler builds on Substack. The question is, how much does it help, right? Like if it made like, so we have about 1,000 people signed up for the beta. Who knows how many are actually in, like, active? Some fraction of that. Um, if you felt that the audience was that big who would pay like $20 a month, that's substantial, right? That pays someone to work on the compiler like almost full time. So if I knew that that would work, I would consider it, but I'm not sure that it's that many people. And, as soon as you just have certain categories of hassles, as soon as you open it up to the wider public like that, I can't find my command that I want to do. But then maybe that's part of that person's job that you're paying is to deal with that. I don't know. Um, yeah, the problem is if you do a poll of this, that's not necessarily representative. And also, so the other thing about that is just, again, once the language is more out there, it becomes harder to change things without breaking people's code. And on the one hand, we've done a lot of that. We've changed a lot of things. So maybe our budget of how much we would expect to change is going down now. Although macros, I'm still not happy with macros. Uh, so I don't know. There's that question of changes being more painful still. If you don't listen to the complaints, they don't exist. Yeah. Yeah, I mean, that's the thing. For most people who program, like $20 a month isn't a lot or something. Maybe it should be more, but I don't know. Like if I say 100 a month, that sounds like a lot. That sounds like, oh, that's expensive. But 20 a month is like, I mean, you already pay that for shitty Disney television, right? So what? Yeah. So maybe I would consider it. This is the thing where too, at some point, if we want to keep the closed beta but grow it to a certain size, we just want a more ergonomic way to get people into the beta, and maybe just letting people pay a small fee for it um is that's just kind of a filter as well, right? Like, are you a little bit serious? Are you going to do something with this, right? Or are you just screwing around? So yeah, I don't know. We would consider something like that. I have issues with Patreon from years ago. They were a really nasty company for a little bit in terms of who they were deplatforming. Um, so I'm not sure that I like them, but maybe they're better now. And eventually we would make it free, right? That's the thing. Eventually we would make it free. Yeah, that might be a good way to expand the beta. I don't know. It would also, the thing that would be nice, um, like right now we're a little bit behind. We're a lot behind on bug fixes, honestly. Um, so getting someone on that would be good. But, if you hire someone to do that, they need to ramp up. They can't, like, I don't want to, like, right away someone is making all these changes. Patreon is shaky. Yeah. The problem is just there is a network effect, I think, a little bit. Maybe there isn't. The other thing is, as soon as you do that, it's going to get pirated all over the place every time there's a release anyway. I don't know. Okay. Okay, so we should be able to look at this now. See, our value numbers are smaller. We probably don't have it in the scroll back, or it's probably hard to find. But last time we called the scroll back's really long. Last time we called this, we were up to like higher value numbers at the end because we were allocating some and skipping them. So now you see V1, V2, 3, 4, 5, 6, 7, right? So that's very clean. So that's good. Now, though, we want to get rid of this intermediate data structure. Who uses this? This thing uses it for returning from a macro, which we want to edit this anyway, but it's using it. Okay. So this is our setup. That's our setup. That's our setup. That's our setup. This is using it when we pull the arguments out of a call. This is one that I think I want to edit first because it's probably the easiest. And then there's inlining. So we have 3 things to do, and then we can get rid of this data structure. So thing 1, it's like Dr. Seuss. Thing 1, thing 2. What am I doing? Okay, instead of this, well, here's the thing. We do not have access to that call info struct from here. So we will add it, fino info. What is it called? I don't remember what's in my data structure. RI, what's RI? Return info. Returns. Okay, easy. Returns.count. Okay. Call info returns sub extract.index. Call info returns.count. Okay. Now, got to go to procedure call. Okay, first of all, return placements is not even used, right? Yeah, literally nobody uses this. I mean, okay. This is the whole thing is like, why? Why did I not go with actual just putting the value placements? I don't know. Anyway, we're getting rid of this. Getting rid of this. Oh shit, no, we do use it. Lol, oops. Okay. Oh no. Let's just revert this file. Because I accidentally undid. I couldn't see what I was undoing because Visual Studio is a terrible editor. All right. I hope. What is going on? Byte. What is going on? All right. Okay. Bing. All right. So good thing we checked in. Okay. I actually. Let's remove this. I already have a line for that. Okay. Okay, we'll look at that soon. This is the thing we actually want to get rid of right this second. It's redundant with all these other things. Okay, where were we? Oh no. I think I messed up because I reverted this. Yeah, it's just the life. It's just the life. All right, we got to do this crap again. Um dun, 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 dun. Call info returns dot count. Um All right, so we need to define that, which is the reason we were here anyway. And we don't know what this is. Oh, it's called local register, not local index. All right. Why can't I just vibe code it? Okay, so we have no... Oh, we're never setting call info, guys. So we'll just have a better ice down here where we say like est extract from a call. Okay. We got to set it. So when we make this, we'll set it. Easy. Made you wonder if anyone tried anything ECS like. I have thought about it a little bit. It's actually hard because if you don't have the pointers going around everywhere, it can be hard to know where to look up data at different stages in the compiler. So I never thought of a design that I was happy enough with to actually try. To be fair, it also would be a large amount of effort. So I don't think we're gonna really entertain anything like that before releasing the compiler. You wouldn't trust to run a pirated compiler? Good point. Good point. I wouldn't want to run a pirated compiler either. There are famous compiler shenanigans that people should know about. Okay. It's almost the regular workday starting soon, which means I got to work on the game and not the compiler. Coming up on 9 a.m. So let's try to finish this one thing. So we want to get rid of that array. That's the goal. Um, what was it called? Return receiving. Okay, let's try the inline. This is one of the scary ones. Just running the tests. We tried sorting a folder of 3,500 photos by date, and it took about an hour in Windows File Explorer. Yeah, nobody was surprised by this. It's so bad, dude. But don't worry. Windows forces you to update and reboot like every 2 weeks, and I'm sure any second now one of those reboots is going to make File Explorer amazing. That's just, don't we look forward to every Windows update with childish glee? Like we just can't wait for how much better our computer is going to get once that update gets installed. I kind of wonder if they're just going to abandon Windows at some point. Because if they think they're going to make all their money off AI shit now, I guess Windows is how you force the AI shit on consumers, right? So maybe that's the plan. Um, okay. We'll take that. That's a very small change. It's fine. Okay. So these are our setup, obviously. And that's the only other thing that's using this, 3024. Where is this? And we're emitting a return. Now, one of the other things is we have this emitting call struct and we have this call info struct. And I'm like, shouldn't these be the same? Maybe. So we'll look at that later. Return receiving returns I.local register. All right. That could be it. Let's try running that. No, not that. Or just keep running the tests. Yeah, I think it would be really interesting to do an OS project. However, dude, I have too many things. I have more things going on than I can handle. And what, like, the way this is sort of the point that I'm at, right? Where I'm able to put a lot of attention into the game and a decent amount into the compiler. It goes back and forth where my attention goes. But I'm approximately doing what one person can do in terms of putting personal attention on things without delegating. And the thing is, these projects are complicated enough that, like, once you start delegating, the teams become bigger and quality goes down. You could try to fight the quality reduction. I'm not sure how successful that is. Um, but it just it starts costing a lot more money to run these big teams. So if I were to do an OS project, like, I just have to have a bunch of money laying around, and I didn't buy Bitcoin in 2008 with my braid money, so sad. Sad. Isn't OS project a lifetime project? Well, you would hope not. You would hope not. Wouldn't the OS project require this to be done? Yeah, I mean, well, I think part of, if you were to scale up and, like, get a team to do these things, part of what you would do is have the team finish the last things on the compiler. I mean, compiler probably continues to get modified for a long time, uh, especially in terms of user space libraries and stuff. But you would, you know, get the initial release and then, start the update train. All right, so that worked, which means, why does it clear my search thing all, like, I have to look up what the thing is? Like, I just searched. Let me search for it again. No. Is there a history? Let's Oh, there is. All right. So now we can get rid of that and that. and that, and that, and that. So we have removed one of the data structures. That's good. All right, we'll do tests one more time, but I think we have succeeded. And then I'll start working on the game because 9 a.m., it's the work day. That was our pre-workday work right there, okay? It's 9 a.m. now, which means we got to ship the game. Dude, if I had only bought, $200 trillion worth of Bitcoin in 2008, I'll do 3 OS projects, man. No problem. Crypto is trash, end of story. I mean, that is true, but fiat currency is also trash. So what are you going to do? Friend had 200. Yeah, I remember I was reading on Hacker News and there was an article about a guy who bought a pizza in New York for like 2.5 Bitcoin. And he was like, isn't that awesome that I can buy a pizza with Bitcoin? Wait, it was 10,000? If it was 10,000, that's crazy. I don't remember how many Bitcoin it was. Yeah, remember when you could mine Bitcoin on your home computer? That was good times. All right. We're going to play one game of cards just to clear our minds of all the Bitcoin we don't have. And then we're going to do game stuff. Wait, did I check in? I didn't check in, did I? Commit, remove, unredundant data structure, which is good because that means the compiler is not spending as much time filling out data structures, right? Okay, 3, 4, 5, right triangle. Should we take the 21? We kind of want the 5 on the 6, but the 11. 11's. I mean, the jack can go on the queen, so we just need this blue 5 to go somewhere. We just need the blue 5 to go somewhere. 6 is down there. 4. 4 is under the blue 5. Okay, the problem is we also want this 3 before the 4, and the 3's under the king. So we got to go this way. That's just how this game rolls sometimes, all right? So we have to cover the 13 that we want. It's like in the Bible, thou shalt not cover your neighbor's card. Um, I mean, we might want blue 7. We could put the 11 on the 10. That would be nice, right? It's just not quite enough headspace to do that. Okay. We got to do this fast. We got to get to work day. We can't sit here playing card game all day. Um I don't know. So we could get the 4, we could get the 2 gold, and that would be up to blue 8, which could go on blue 7. Okay, this actually works if we do this. Right? Um because these come together. See that? See that? We made a decisive decision. We decisively decided. This 9 and 6 go. These would make these one thing. 4 goes on the 3. Right? Easy. Easy clap. Okay, this goes now. That's great. Then this could go with the red 2, but we kind of lose our slot there. Red 9. Oh, it's not so good. Not so good. We want this so we can get this queen in here so we can manipulate this, right? Or we could just try to get to this 2. We could eat our slot and do a bunch of stuff here and pop 2, 3, 4, 5, and then 19 on the 18. Um, Let me just look really fast to see if there's anything else. This would give us 3, 4 blue queen. Let's do this. This also eats our slot, but that lets me do this. Okay. And then I can trade this out. So we're still in trouble. So if I put this 13, 10 on the 9, 2 goes 18 on the 19. No. 19 on the 18. Yeah. 13. 10 on the 9. 19. Okay, so we're still in trouble. But now we do this. And we get all that. That's great. Still in trouble. Okay. Okay. How do we save our bacon? This queen is still hosing us. It's a problem. Okay, we'll do this swap Rooney, and that gives us the 3-4, and then we're fine. All right. We're out of the woods. Boom. Okay. And that's a wrap. We got a good card. All right, see? Easy game. Let's start going on game stuff. Now, let us update the game. I should have done that while we were in the cards world. Okay. Let's make sure this is updating correctly. Uh-oh. We're not getting builds. We ain't got a build in an hour. Actually, not since. Am I getting build emails about something being broken? Um, uh-oh. We also have a bug report. Two, 4, 9. Okay, well, it is very sad, but we have now two different problems. We're not getting builds of the compiler. God only knows why. I'm going to go back and look at the build machine over here. Pardon me while I investigate. So like we have a bunch of servers that do a bunch of crap, and they're not named things with names that I understand, and like it looks like one of them's not running, but I don't know which one. So like do I just reboot the machine and hope that it all works? I don't know, man. What the hell? Okay, let me see. Okay. I somehow miraculously found the right server to start, even though the documentation has wrong file names and all these things. The fact that the server went down is not necessarily good. Maybe we introduced a compiler bug or something, but also what I have been told is that we now have a problem in the game where the materials panel in the editor doesn't work. And that could easily be caused by my changes. So let's try to investigate that while we hope that the compiler build gets better. All right. Okay. So if I open the materials panel, attach debugger. However, that's weird. All right, let's see what's going on. See, this is a problem. You can have a bunch of tests, but maybe maybe you broke something that wasn't in the tests. Cast bounds check fail, load font part 2. Okay, is this a macro? What is ft set pixel sizes? This is in retype 255. All right. What were you looking for? Set pixel sizes? ft set pixel sizes. Foreign function. Okay. So that's fine. Base pixel height -2. Cast bounds check failed. Oh. Okay, why is our pixel height negative? It's 00 negative. Why is that? That's a parameter to load font. It's still -2. Get font at size. Still -2. That's a parameter there. Draw graph section. Section height. -2.3. Transform graph to panel dimension. So we're returning a struct and then taking the Y value of that struct. This is the kind of thing that we have been working on, and so I'm not that surprised if it's broken. All right, so we've got a breakpoint there. Okay. Transform dimension. So I fucking hate functions like this where they don't assign things to a variable and you can't see. Like, what is this code? Like, all it's doing is dividing, it's like scaling some stuff based on a thing. Why? Yeah. What is going on? Like, I can't see the fucking value though, because there's no variable. Thanks, guys. All right. Now, if debuggers weren't awful, you would be able to see that. You would be able to see like, oh, the return from the function is this. But, you know, debuggers are not good. So, no. Uh, uh, so we're obviously just doing something bad with not copying the return value correctly or something. Which is weird. It's weird that's because none of this code is doing anything fancy, right? So, like, what did we do? All right. What do we got here? Result. It's already negative. Okay, so maybe this code isn't the problem, right? Okay, target is negative. So obviously, yeah. All right, so that's fine. We just keep looking for the problem. Um, wait, node title height. Okay, what the fuck is that? Like, debuggers are still so bad. Wait, node title height is 4.0. So how did we get negative, right? That's, did we pass the value? And but it's not like they're random memory. It's like they were actual negative numbers. This might, okay. This actually might not have anything to do with anything I was doing, by the way. Let's be clear about that. I'm assuming it's my fault because that's a smart thing to do when you're a programmer. However, okay, so this is 4.4. Oh, but it's graph view, which is like a global or some shit. Panel view. It's panel view, which is a global. What fucking not good code is this? Panel view. Where does that get set? Yeah, this might just be due to someone else's changes for all I know. Actually, I was told what is the revision number. Yeah, okay. He says it was from the compiler. Okay. So it's probably my fault, but let's see. Make view, panel view factor times a bunch of stuff. So 516. This is why it's good, even though we have all these tests, right? If this is something I broke, the test didn't catch this. So, um, you know, let me just see when this was. So he says 24946 is when it broke. Is that from today? It's probably not. It's probably from before. Wait. What? Uh, 24946. All right, this is from last night. He says 24945 worked. Well, this is when I moved a bunch of placement stuff around. Pretty big changes. So not that surprising if that broke something. Let's just see if we can debug it. So panel view. Panel zoom factor. Okay, rect panel view. That's some numbers. Panel view displace. Apparently I can't. It's unknowable what this is for some reason. Fucking debuggers. All right. This is using DOF something else and the debugger doesn't understand that. It's on the panel. Okay, that's 0. That makes it easy. Let's just go in here. What is this fucking code? Like, this was written by someone who does not like you to know what's happening. All right. So that was fun. So we ended up with a negative number. And we can't inspect it because, again, the arguments are like fucking... All right, so size is negative. Off is reasonable. So panel view zoom factor. How about that? One. Rect panel view dot h is negative. Wait. X, Y, W, H. Okay, so that's fine. Where does that happen? Cut bottom, body rect, graph footer height. What is body rect? Body rect. Okay. That's not good. We're getting somewhere. Graph rect. Denormal. You don't want to see that. That is a return value from this thing. We are going further back in time to the root of the problem, which we all know, as we've been taught by the smart people at universities, is really colonialism. So we're just going back to find the roots of colonialism. Okay, so like don't write code where you call functions as arguments to functions. Just don't do that. It's really fucking annoying to step through. Don't ever do it. Do not ever type this. I know it looks like all tight on one line when you do that. It's really annoying. What is this? All right. Okay. Rect. It's already denormal. Group. .rect.y is trash. Actually, this whole thing is trash. Group.rect. So group was passed in. Group. Group .rect still trash. Okay. So we need to trace further back to the roots of colonialism. Let's see if content rect. That's already trash. Good thing we didn't bother to step in there. All right. Where does content rect come from? Up here. Okay. This is a comma separated assignment. All right, we're going to have to step through that. Comma separated assignment is what we were doing these optimizations for. So it's not that surprising if it broke. Guys, I think I know what the problem is. Although if this is true, I have no idea how any of this code works. But remember when I said, hey, we're generating this L value because you just need one? And maybe that's a bug, but the code needs it. That L value is not attached to the storage in any way. So I think what's happening is we're returning a big value here, and then someone's trying to refer to it by that register, and like the register is just not attached and points to trash. That's what I think is going to happen. So we're returning. Wait, it was the first thing though, right? Content rect, comma, used content rect. Why is content rect? Oh, wait, we inlined a thing. Why is with horizontal scrolling force inlined? Hold on. Is this going to make me baby rage? I'm sure it is. Look at this giant ass function. Oh, it's a macro. Why is this a macro? Because it's got a backtick defer. Oh, guys. No. What's wrong is returning from the, yeah, returning a big value from a macro is broken. And I knew that in my brain. And all right. Let's repro this. This is how you get her done. Macro vector thing. Let's return a thing. 1, 2, 3, 4. All right. I knew. I was working on so many things. I knew this was probably broken. All right. Thing is a struct. X, Y, Z, W are floats. All right. We have a macro that returns a thing. And we're going to go thing is macro print the thing. All right. Like anytime, if you're able to make a very simple repro for a problem like this, I mean, it takes some time to do that, but assuming that you're able to do it with relative efficiency. Okay, well, it worked. Dang it. Anyway, though, I am pretty sure this is the problem. Where we could like copy this and try to repro it, but um why are we returning why are we returning a thing and the pointer to the same thing? Yeah. This whole thing, so this is part of the UI system that somebody wrote that I hated that I then replaced by writing getRect. So getRect exists because this code made me angry. Um, and in the process of making getRect, I deleted a large amount of this code. However, not all of it, unfortunately. Um, so we're going to have another thing where some maintenance people might come by soon. If that happens, we might have to take a short stream break. Okay. We could we could just do a little bit of printf. I want to validate that this is the problem before I go work on it. But I'm pretty sure I know what the problem is. But let's verify. So where were we? Here. So upon returning from this, these should be the same, right? This is a pointer. This is a value. So we're going to go in there and go to 1327. We're going to go here. No, not that. That. Okay. Here, materials panel. Okay. What do we got? I mean, it looks right. But here in the debugger, it doesn't look right. Okay, so now we have a problem. Can we trust our debug info? Maybe the debug info is confused. Okay, let's see what rect is in here. Rect is fucked up. So I think what's happening is, yeah, the print. Let's just do a couple things here. The print got the right version of it, but that's because it was the memory version, not the L value version or whatever. Um, yeah, let's. Okay. I wish I had a smaller repro for this, but our repro didn't. Oh, you know what? Like we said, the print was fine, but if we go f of thing, that may not work. Let's see. It worked. Dang it. I wanted a small repro. Um, okay. So like I said, there's sort of two things going on here. There's this thing. Um, but I don't know if that is relevant to this. So scalar placement is used if we don't have one already. Um, but the reason this is used is because we don't respect the placement down here. See, we're trying to do a thing where we just shove a register, and I guess that worked for a while. But like, we actually need to, if it's big, we need to do a mem copy. Um, we could do some cowabunga oriented programming here first. We could say, um, okay, what happens when we do a return? inside a macro. Okay. Literally this thing. That we can't use return. That's a keyword. So we're going to do this. If ret arrow what is it called? This thing that we set. Right? So this is if it's a big argument, if it's there, we have this value number for big return value destination address. So report info cowabunga. All right. That is our cowabunga oriented programming for the moment. Well, we got to recompile our compiler. We don't have the compiler open. Come on, man. We're going to use debug build. It will be a little slow. Oh boy, look at all the cowabungas. Look at all these macros getting used in default allocator. It's fucking macro city. Dude, if this is the bug, I'm amazed anything works. Look at all these macro. Look at all them chickens. Okay. So I mean, just to check what we do, but this will be like in the back ends. Oh, we could look in the bytecode runner, right? So okay, wait. This is just doing the same thing the macro is doing. So this is for C calls only. This is just the same value that's in this slot always, which is why it's marked redundant, and we want to go later and maybe do a sweep and clean it out. At this point, so what that means is this does the assignment. But we don't actually put anything in there. I'm tempted, so I want to go back to our actual bug. Because the repro, the simple repro that I made, does not exactly repro the bug, the question is, do I really understand the bug right now? Right? Unfortunately, I closed the frickin' debugger that had that thing open, so I don't remember where it was. We added some print statements in there, right? So we could find it this way. Material panel, line 200. Yeah. So I'm going to do a dump here, and this is going to be a big dump. Okay, let's remove the cowabungas for, well, we'll try to read through the cowabungas, but we might remove them if we have to. They shouldn't happen in the middle of the dump. That's a lot of cowabungas, dude. It's just what happens when you have a program this big. All right, we might take those out after this build, but why do we have uninitialized line numbers going on? All right. Okay. So we are doing with horizontal scrolling. That's line 1327, 1325, 1329. So this is probably, so this is UI 565, which is with horizontal scrolling, right? So let's see if we can figure out what's going on here. We do all this stuff. And then at the end, we're 589, 589. So this is the return statement. We're copying these values. And we're mem copying here, which I was worried that we weren't. Oh, that's just this. So we're mem copying from used content rect to initial content rect, right? So then we're putting V37 and V36. So V37 is the one that's messed up. And yeah, so here's the thing. This is the problem. V37 is the address of something on the stack. Okay. We are never filling in that address. We are changing the pointer so that it doesn't point at that stack address. Okay. That's not good because if somebody else uses this stack address, they will get the wrong answer. And they may use that stack address. Let's see. So here's our print functions. See, this is putting v37 in, which is the changed pointer. Okay. But the problem is, again, the stack space is uninitialized. So let's look if we can find a place that does that. Stack plus OX30. Let's, if we didn't have so many cowabungas, it would be easier to do this, but. Oh boy, look at all the code. Look at all the code. Sure is big. Sure is big. We could, yeah, we could redirect that to a file. All right. Copy. Paste. So stack plus OX30. There we go. V109 is pointing to, unless someone in the middle filled it out, which I don't know, V109 is pointing to uninitialized stack space. And then we're putting that in begin foldable column group. Now there are two things here. One, obviously we can fix this bug by filling in the stack space. But two, is it legit? Is it legit to be assigning the L value like that? Like, I don't think we should do that. Why are we doing that? But that's a bigger change. Like, I want to stabilize this bug so that um, people don't have a problem. So I want to just add the mem copy. So we don't seem to do anything here for big arguments. Hmm. Yeah, I just need to, this stuff, there's just a lot going on in a compiler, and it's just hard to think about it all at once. And it becomes confusing. I need a bigger brain to do all these things. So so did we cowabunga? I mean, we have to scroll a long time again. Did we cowabunga right before this is the question. This is what we want to know. With scrollable region with horizontal scrolling. Yeah. So was it 1327? 1327. So that's our cowabunga. So if we put this mem copy, it should refix this problem. It's going to add frickin' hundreds of instructions back to our compiler, which makes us sad. But then we need to figure out what we may remove hundreds of instructions from our compiler if we're like, wait, you shouldn't be doing this other thing. Okay. So really what this should just be is like a flag or something that says, this is a big return value. Although we could also just detect that. So that's like not a hard thing to detect. But maybe we want this code to have choice about how it sets these up or something. Okay. Let's just try it. We're going to try it. So we're going to have to explain why we're doing this. Yeah, I don't like that we're assigning this here at all because this could cause other problems. The fact that we have a stack memory and then an L value that are now desynced can cause even subtler bugs than what we're looking at right now. However, I need to fix this for the people. Like some people might be trying to run the game and they're fucked right now. Um, and uh, I just need to review what's the policy here. So we might do another simplification stream later. Okay, so before we do the copy, we're going to potentially do a mem copy. All right, so instruction mem copy sized. The destination, the source, the size, and the line number, which is easy. The size is, we got to get that somehow because it's not in the return info, right? Let's do this. We're just going to have a good name for that. Okay. Take the address there. So here we're getting the declaration of info arrow lambda type lambda return declarations sub I. Okay, maybe that works. Maybe we just like literally broke some stuff real bad. Okay, we broke some stuff real bad. So like I said, default allocator has a ton of these macros. So this is the question, is why would this be the right thing to do sometimes and not other times? That doesn't make sense. So supposedly this is a valid L value if it ever gets set, right? Oh, wait a minute. Guys, this is a value number. Guys, this is a value number. You know what that means? When it's not set, what is the value? The value is -1. What am I doing here for my cowabunga? Why are there so many? It's because we cowabunga'd like literally everything in the universe. Literally everything in the universe. All right. That's a lot fewer cowabungas. It's still a lot, but it's not as many. Dude, why can't I just have a shell that lets me run the commands? Like, why has everybody who ever ported a Unix shell to Windows made a poopy thing that is terrible? Like, all you want on Windows is the Windows shell, but like, let me do the exclamation points and all that stuff. That's what you want. Hey, look at that. Hey. All right. Let's run this on our test. See, we just debugged in the earlier days when I was first in video games, just out of college. Fixing that bug was a minimum 2-day fix. We just fixed it in like 20 minutes or something. It might have been a week bug. I don't know, a week long bug. I don't know. Okay. We need to review what is the right answer in this case with regard to returning big values. We are assigning the L value here and in CTE, but I don't think that is right. If the L value diverges from the stack storage, that is a bad thing. August 2025. So you can definitely, why is it -1? Because it's an index to an array and 0 is a valid value number. In the olden days, in the early days of the compiler, we did the MIPS thing, um, where 0 meant 0, but that was annoying, so we took that out. Oh, I got rid of the scalar placement, by the way. All right. That's good. We got rid of that. I forgot that we had even commented that out. All right. So I'm going to do a commit. I'm not afraid of commitment. What do we say here? Fix a bad behavior in macro large return values. There is more to do here though. All right. Cool. I will send the email. I just fixed this. Hopefully the art team did not have too much of a problem. Okay, so I've sent the email. And that's pretty good. That's pretty good. And that might be my morning stream. I just wanted to pop in and do a little bit of stuff at the beginning of the workday. Um, I mean, we wanted to do some game stuff there, but we got derailed by bug. Um, but yeah, are there any technical, excuse me, any technical questions about what we did? It's 2 days, one work and one morning. Yeah, basically. Basically. See, so that's the thing I was going to say too, is like the fact that we have a giant complicated game is very useful. Like all of our tests passed, right? It was only a weird thing on the game that crashed, and it's even something that I didn't notice. Somebody else had to notice, right? Um, because we have that, we notice these things before we ship bugs to our beta users, right? It doesn't mean they don't get any bugs. They do get some bugs for sure, but they get fewer bugs than if we didn't have our own giant complicated project, right? So that's the other good thing there. Our tail calls special. No, we're not retarded. If you're a tail call enjoyer, that's fine. Um, I don't I don't see the point. This is not Haskell. We don't loop by recursing infinitely, so I don't think it's a priority to do tail calls. What's the deepest recursion loop you had? I don't know. We don't measure. We do some recursive things sometimes. But usually when you have code that's recursive, it's relatively complex, right? And you'll come back and do something after you call another function, right? And so having this weird optimization that's only like, well, you don't use more stack space if you return immediately upon calling it's just, who cares? Like, what's the point of that? Like, if you change your code slightly, that breaks and now your code doesn't run if you were depending on it. Like, it doesn't make any sense. And like the idea of saving stack space doesn't make sense. Like, stack is really small compared to the rest of the memory of your computer, and it's really fast because it's always hot and in cache. And so like what do you think is the optimization? Like, do you think not having like a, like, I don't even know. I don't know what, I mean, aside from the ability to recurse infinitely if your code is tweaky and set up just right, I don't know if people think there are other benefits to tail call optimization, but I don't think there are. How long does it take for a human tester to test the entire game? We don't exactly know because nobody has done that yet with the game as close to completion as it is. However, we do have people playing it right now. They're something like 120 or 150 hours into the game. Um, but these are people who are very good at puzzles, and you could expect them to be faster than average. And there may be, I don't know. We need to go do a puzzle count, but we don't require you to solve all the puzzles to make progress in the game. And so by that metric, by not necessarily doing all the puzzles, uh, but just going forward and exploring, they're probably both not quite at the halfway point of the game. Doesn't LLVM do tail call recursion optimization? Maybe, but we don't, right? And so if you're not using LLVM backend, you wouldn't get that. Is there a directive for compile time global array element assignment? There's no directive for that, but that's something that you just do with code. So you can. Oh, okay. There is a directive that says whatever this array is at the end of compile time, we would like it to be maintained, right? Um, but yeah, you can like there's multiple different ways to set up arrays at compile time actually. Yeah, I don't understand why people like tail call optimization. I mean, unless you're literally using a programming language where it's haram to have a loop because loops don't exist, right? Tail call optimization was really nice back in 1982. That might be so. Functional bros tout it because it makes their program fast, TM, but it like it doesn't do that though. It doesn't do that. I mean, it does if the memory model is that your closure is like out on the heap somewhere, then maybe it means you're deallocating it off the heap right away, but like you still are allocating and deallocating it off the heap. I don't know. I don't know. It depends on the implementation details of the particular compiler. You know how people all the time say like so and so optimization is amazing, and then if you were actually to measure it, it like doesn't actually do anything. Like this might be one of those. If you're in Java and the call stacks are in the hundreds, I mean, if the call stacks are in the hundreds, that's fine. Like what? Let's say you have 16K on the stack. That would be a very big local stack for a function. In every function, and you have 100 of 16K, right? That's 1.6 megabytes of stack space. Do you know how small that is? Like the icon for your program is probably bigger than that. It's just like, who cares? Some algorithms make more sense recursively. Yeah, but it's not just that the algorithm is recursive, but it has to be recursive in such a way that the function call is literally the last thing that you do. And like, that's just a very weird restriction. Like, why do you like that, you know? The idea of throwing out loops just seems super dumb. That's okay because the new thing is you pretend your loop executes in parallel and then it's not a loop anymore, right? Because the reason they don't like loops is because you're changing the iteration variable. But if you're really doing n alternate realities that all have their own instance of the iteration variable, then loops are totally kosher, right? Because they're not loops. So that's the new thing that functional bros like. A lot of for loops can be optimized with TCO. No, no, they can't be optimized with TCO. What do you mean? You mean that if you turned your for loop into a recursion instead of a for loop, then you wouldn't take as much of a hit from doing that with TCO. I agree with that. I don't know, but I'm not a functional bro, so yeah. What's the double comma syntax? That's secret sauce. All right, thanks everyone. Let's try to find somebody to raid again because we've got a lot of viewers and we want to take care of our viewers. But you know what? We don't uh we don't often we don't often have a very easy time trying to find people to raid. Let's see. Who have we got? Optimizing Linux. Well, that it needs it. Coding for challenge mode. Play Dungeon Mans. We rated him last time. Random modding. Game reviews. Programming language Monday. Rewriting the compiler in Go. What compiler? Okay. We could send you to that. I don't know what compiler it is. But since we're doing compiler, let's do that. All right, thanks everyone. See you later.